Question number 8. How many regular polygons having more than 4 sides are possible such that the value of interior angle is an integer? Since in the question it says regular polygons and the interior angle of an integer, so for any regular polygon, the value of an interior angle is given as 180 degrees minus 360 degrees divided by n, where n is taken as either the number of sides or the number of vertices, they both being the same. Now, as per the question, this is supposed to be the integer value. This is only going to be an integer if 360 by n is going to be an integer, and 360 by n is going to be an integer if n is going to be a factor of 360. Right? Because the first term is already an integer, it's not a fraction. So this question is not a question on mensuration, but rather a question of numbers. We need to find out the number of factors of 360 degrees. Well, 360 is 2 to the power 3 into 3 square into 5 to the power 1. So the number of factors of 360 is going to be 3 plus 1 into 2 plus 1 into 1 plus 1, which is going to result in 4 into 3 into 2, which is 24. Since there are 24 factors of 360, that would mean that we can actually have 24 such cases where this is going to give us an integer. Now, the thing is, we cannot have the value of interior angle as 0 degrees, right? So, out of all the 24 factors of 360, we won't be able to include all of them. So, what are the values that we cannot really take into consideration here, right? So, if we take n is equal to 1, it will become 180 minus 360, you will have a negative. So I can't take 1. Next, n is equal to 2, as in the other factor of 360 is 2. If I take 2, 180 minus 180 is going to be 0. Okay. In other words, we can't have a regular polygon with 1 or 2 sides. What if we take 3 sides? We can't take it. What if we take n is equal to 4? Since it says more than 4 sides, as in square on up to square, we can't really take it. So these 4 values we can't take it, either being the interior angle is going to be 0 or negative, or as per the question we can't take the value of n up to 4. So these 4 values we need to subtract. So there are going to be 20 such values of n that are acceptable values. So the answer is going to be 20.